Hello, in this video I'm going to be working through some trig equation questions, and these are going to be in radians rather than in degrees. So if you want to work through these questions with me, it's going to be really important you've got your calculator in radians mode, otherwise your answers are going to be completely different to mine. Now, to do this video, it's going to help if you already have some knowledge on solving trig equations, and if they're quite new to you, I'll link the videos I've made on that topic in the description, and I'll also link my website so you can go over there and it's a bit easier to navigate through all the videos I've made. Okay, so let's look at this first question where we're solving cos of x equals negative 1/2, and we're solving this on the interval between 0 and pi radians. And we're going to solve this the same way we did with any other trig equation, and what I like to do first is just draw out a sketch of the graph. And so we're going to sketch cosine of x between 0 and 2 pi radians, or 0 and 360 degrees, just to get that first initial period. So it starts off at 1, goes down to negative 1, and then comes back up to 1, and it's labelled on these key points. It's pi over 2, pi, 3 pi over 2, and 2 pi radians, like this. So we want to know where the graph outputs negative 1/2, and if I zoom in, you can kind of see we expect that to be somewhere around here, because the graph is going between 1 and negative 1, and so negative 1/2 is probably this point here. And so to find out where that solution is, what we're going to do is go on our calculator, make sure it's in radians mode for this, otherwise you'll get a completely different answer, and we're going to do inverse cosine of negative 1/2, and that's going to tell us what x equals. So we're going to type in inverse cos of minus 1/2. And when I do that, I get x equals 2 over 3 pi, which means if I zoom in here, 2 over 3 pi is going to correspond to this solution here, so that's 2 over 3 pi. Now, using the symmetry of the cosine wave, I can say, well, if I've gone 2 over 3 pi to the right of the origin, if I go to 2 pi and I go back 2 over 3 pi, that's going to take me to this other solution, which is right here. So what I'm going to do is do 2 pi minus 2 over 3 pi, and that's going to give me my second solution that I'll write over here as x equals 4 over 3 pi. Now, something people sometimes struggle with when solving trig equations in radians is telling whether a solution is in the interval you're solving in. And so something you can do if you want to help you out is to rewrite it so that there's no pi in it, just write it as a decimal. So we're solving between 0 and pi, or pi is 3.14 approximately. So if I have any solution between 0 and 3.14, I know it's okay. So if you couldn't tell, you could say, well, is 2 over 3 pi between 0 and 3.14? And you could check by typing it in your calculator, converting it to a decimal, and for this one I get 2.09, so that's all good. Let's do the same with the other solution, so 4 over 3 pi is a decimal, and I get that that equals 4.18, which is, as you can see, beyond 3.14, so we're going to reject this solution and accept this one here. Now, if you wanted to see if there are any other solutions in this interval, you could add or subtract the period of the graph like we do with any other trig equation. But hopefully you can see we've actually accurately sketched the trig graph between 0 and pi, and we can see that there's only one solution here. As well as that, the period of cosine of x is 2 pi, so if you add or subtract 2 pi to this answer here, well, you're definitely going to be outside of the interval. And so we're done, and there's only one solution in this interval for this trig equation. Let's now look at the second question, where we're solving tan of 2x equals 3 between 0 and pi radians. So again, the first thing I'm going to do is draw a sketch of the graph. So I just draw the first sort of period of the graph. So it starts off at 0, goes up to this asymptote, which is at 90 degrees. So in radians, that's at pi over 2 radians. It then goes down to negative infinity and comes back up to 0 again after pi radians. And so we've drawn out this initial period. So what we do next is do inverse tan of 3, and that tells me what 2x is going to be equal to. So 2x equals inverse tan of 3, and I'm going to type this into my calculator. And this tells me that 2x equals 1.25 to 3 significant figures, which is probably going to be this point over here somewhere, I'm guessing. Now, if it helps again, you can rewrite the interval in terms of just a decimal, so 3.14. Now, with tan, there's only ever one solution in each period, so we don't need to worry about using the symmetry like we do with sine and cosine, and so I can go ahead from here and divide by 2. And when I do that, I get x equals 0.625. And I can clearly see that's less than 3.14, so that's a valid solution. And so now, to see if there are any other solutions in this interval, I'm just going to add and subtract the period of the graph. So the period of tan is pi radians, like we said earlier, but we have this 2 in front of the x. And what this is doing is it's stretching the graph's scale factor 1 over 2 parallel to the x-axis. So originally the period was pi, but what this is doing is halving the period and so the period is pi over 2. And so I'm going to add and subtract pi over 2 from this solution to see if there are any others. Now, if you subtract pi over 2, you get a negative number, so that's obviously not valid. And so instead, let's add it on, and I get another solution of 2.20 to 3 significant figures, which is in my range of valid solutions. And if I add on pi over 2 again, I get 3.77, which is outside my range of valid solutions, so I'll reject that, and I will just accept these two solutions here, and we're done. Let's now look at the final example, where we're solving sine of 2x plus pi equals 1/2 between 0 and 4 over 3 pi. So again, to kind of make it a bit easier, I'm going to rewrite 4 over 3 pi as a decimal, and that's 4.1887. So like always, I'm going to sketch out the graph of sine of x, and I'm just going to draw out this first period between 0 and 2 pi, and label on a few key points like this. There we go. And then I'm going to do inverse sine of 1/2 like I always do. So inverse sine of 0.5, and that tells me it's pi over 6 radians. So 2x plus pi equals pi over 6. So let's zoom into our graph, and we can see that must correspond to this solution here. And so I've gone pi over 6 radians to the right of the origin, and so using the symmetry I'm going to go to pi and go back pi over 6, and that's going to take me to this second solution here, which is 5 pi over 6. So let's write that in. So 2x plus pi could also equal 5 pi over 6. Now I've got both of these solutions in the initial period, I can now rearrange to make x the subject. So for the equation on the left, I'm going to subtract pi from both sides, which gives me 2x equals negative 5 pi over 6. And then I'm going to divide both sides by 2, which gives me x equals negative 5 pi over 12. Now for the equation on the right, I'm going to subtract pi from both sides, which gives me 2x equals negative pi over 6, and dividing both sides by 2 gives me x equals negative pi over 12. Neither of these solutions are in the interval we're solving in. You can see that straight away because they're both negative. However, they're still useful to us because what we can do now is just add on the period of this graph until we jump into the solutions that are in the interval we're solving in. And so if we take a look, we're solving sine of 2x, and so just like with the previous example, this 2 in front of the x is a stretched scale factor 1/2 parallel to the x-axis, and so it's going to half the period of the graph. So we were dealing with sine of x, which had a period of 2 pi, and so we're halving this, so the new period of this graph, let's write it down, is just 1 pi, so the period is equal to pi radians. And so I'm just going to add pi radians onto both of these solutions until hopefully I find all of them. So let's start off with this solution on the left here, and let's add pi to it, and that gives me x equals 7 over 12 pi, which is a decimal, it might be helpful to write this down, is 1.83 radians, so that's acceptable, that's in my range of solutions. If I add pi on again, I get x equals 19 over 12 pi, which is a decimal, is equal to 4.97 radians, and so you can see that's outside the range that I would accept, so I can reject that solution. Let's now go to the other solution we got, this one here, negative pi over 12, and let's add pi onto it, so let's add pi to that, and that gives me x equals 11 over 12 pi, which is a decimal, is equal to 2.88 radians, so that's all good. If we add pi on again, I get x equals 23 over 12 pi, which as a decimal is equal to 6.02, which again is too big, so I'll reject that solution, and you can see we end up with just two valid solutions for this equation, x equals 7 over 12 pi and x equals 11 over 12 pi. So hopefully this video was useful. If it was, please do go over to my channel where I have loads of other maths tutorials, and you can also go over to my website, which I'll link in the description, where you can navigate through all of my videos in one place. Thanks for watching.